Hey guys, 2.4 day 3, tangent and normal lines. This is the last lesson and you're going to have 4 problems for homework to go with this. And then you're also going to have the chapter 2 review worksheet. Yeah. And I went ahead and I made it on Edulastic, so you'll be able to do that on Edulastic, so you can practice typing in stuff how you would see it there, because guess what? Our chapter 2 test will be in Edulastic. Okay? All right, so today is about tangent and normal lines. So this type of normal is not the normal that you're thinking of. It has a specific definition as far as math goes. So it says, recall, when given a point on a line and the slope of the line, you use point-slope formula to write the equation of that line. So when you have a slope and you have a point that's on that line, you plug in the point, the x value and the y value, you plug in the slope, and then you have the equation of the line. Okay, it's pretty simple. In calculus, though, we write the equation of the tangent line to f at x equals a in the following way. F of x equals f prime of a, which is the derivative of f of x at that point a, times x minus a plus f of a. Well, what happens is that this is the same as that. It's still point-slope form, and we know that the derivative of a function is the same as the slope, because it's the tangent line to that curve, okay? So it's the slope of that line at that point. And so yeah, let's show that these are the same. So let's show it. So if we have y minus y1 equals m times x minus x1, let's do a comparison. If these are the same, that means that x1, y1 will be the same. So if we have x1 should map with a, and y1 should map with, so that y1, pretend it was added to the other side, that means it would be the same as f of a. So these should be the same. If they're the same, then the same thing goes with the regular x and the regular y. Okay, so if we have a regular x and y coordinate, x should be the same as that x, right? And y should be the same as the f of x. Okay, so knowing that, let's proceed. We're going to show that the point-slope formula and the formula for writing the equation of a tangent line are the same. So what we're going to do is we're going to substitute in what we know, what we got from here. So we're going to substitute. So instead of y, I can put f of x minus, instead of y1, I can put f of a, and m I can keep as m, and then x is itself, minus x1, I can substitute an a in. Okay. Well, let's go ahead and add f of a to the other side. So it will look like this. It'll be f of x equals m times the quantity x minus a plus f of a. Okay. And now, let's point out what this is. What does m stand for? Well, duh, Mrs. Garcia, it stands for the slope. Y equals mx plus b. So, right, it does stand for slope. So m stands for slope, which is the same as finding the derivative at that point. So it's the same as f prime of a. So, because that's the same as the slope, f of x equals, now I can replace the m with f prime of a, times the quantity x minus a plus f of a. So they are the same. If they weren't the same, it wouldn't have come out exactly like this, okay? But it's exactly what we get in the original, okay? So example 1, we're going to write the equation of the line tangent to y equals x squared at the point 1, 1, okay? So the first thing we got to do, because we're finding a line that's tangent to this graph, we need to find the slope. Okay. When we're finding the slope, we're taking a derivative because we're finding the slope of the tangent line. So let's find the derivative. So we'll say y prime equals the limit as h approaches 0 of, I'm going to plug in the x plus h, so x plus h quantity squared, and then you have to subtract the original, which is x squared, all over h. Okay. And then in the next step, I know that x plus h quantity squared multiplies out to x squared plus 2xh plus h squared. Okay, so let's rewrite this. So this will be y1 equals the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. Okay, we can get a little cancel happy because these are opposites, so they gone. And then all we have left is 2xh plus h squared all over h, so we can cancel out an h because remember, it's all or nothing. So we'll get y1 equals the limit as h approaches 0 of, I have a 2x and I have a plus h. Okay. Well, from there, we can plug in the 0 for h. 2x plus 0 is just 2x. So that would be the slope formula. Okay. So now we need to find what the slope is, but we were given this x value because it's got to be at that point. So that x value needs to go in there. So that'd be 2 times the x value is 1. So that means that the slope of that tangent line is a 2. Okay, we have the slope. We have a point that it's on. So now we have enough to write the equation of the tangent line using this. So for the tangent line, I'm going to have f of x equals f prime of a. That's the slope. So we got the slope is 2 times x minus a. So x minus the x value of the point is 1 plus f of a, which is the y value of the point, which is also 1. So plus 1. I'm not done yet because we've got to simplify. So we have to distribute. And that will get me a 2x minus 2 plus 1. And we just need to simplify that. So our final answer then is f of x equals 2x. Negative 2 plus 1 is negative 1. So 2x minus 1 is the equation of that tangent line. Okay. Now it says check it by graphing. Okay. Easy enough. We can do this. So the equation that we have is y equals x squared. That's a parabola. So we know it has a vertex at 0, 0. If I plugged in a 1, we'd have a 1, 1, negative 1, 1. Plug in a 2, 2 squared is 4, and negative 2 squared is 4. So our upward facing parabola. I'm really proud that my drawing looks pretty decent right now, so I'm having a really proud moment. Anyways, okay. Y equals mx plus b, because this is a line. The y-intercept is a negative 1. So I'll always start there. And then move according to the slope. It's a 2, so if I make it a 2 over 1, I'm going to go up 2 over 1. Up 2 over 1 puts me at, oh, look at that, 1, 1. The point that it's tangent to. Up 2 over 1. And I'm going to try really hard to draw a straight line. Oh, well, I guess I could have tried a little bit harder, but oh well. Still pretty darn good if I do say so myself. Here's our tangent line to the curve. And I should also label the function f of x. And there we go. We verified it. That's exactly the line that we got. And it is tangent at that point to that parabola. So we done good. Turn the page. Page 2. We're on example 2. It says find the equation of the tangent line to the hyperbola y equals 3 over x when x equals 3. Okay, so again, we are finding the equation of a tangent line. So we need to start with, what do you think? If you're thinking slope, you're on the right track. Got to find the slope. That means we have to take a derivative. So we have to find y prime. So we have to use our little x plus h formula thingy. So we'll have it equals the limit as h approaches 0 of 3 over x plus h minus the original, 3 over x, all over h. All right, I got to clean up that numerator, which means I got to get a common denominator. So they both have to have this factor of x plus h and x. So I need to multiply this first fraction, top and bottom, by x, and the second fraction, top and bottom, by x plus h. What color do I want to use? Okay. So now we're going to have the limit as h approaches 0 of, we know it's going to be all over h, so at least that's easy. And then in the numerator, the common denominator is going to have a factor of x and a factor of x plus h. The numerator, I'm going to have a 3 times x, which is 3x, minus, because I have a negative, basically 3. Negative 3 times x is a negative 3x. Negative 3 times h is a negative 3h as well. Okay, we can clean that up some more. So I'll put it down here because I'm running out of room. So we'll have the limit as h approaches 0 of, well, 3x minus 3x, they gone. So I'll have negative 3h over x times x plus h, but it's divided by an h over 1. So dividing fractions easy as pie, flip the second and multiply. So multiply by 1 over h. And that makes it so the h's cancel. They gone. Okay. So now I have the limit as h approaches 0. I have a negative 3 times 1, which is just negative 3, all over x times x plus h. Okay. We could plug in that 0 for h. And x plus 0 is just x. So I'll have negative 3 over x times x, which is x squared. So there's my slope formula. Now we need to find the slope. We know what x value to use because they told it to us. It's a 3. So let's plug it in. So we'll get negative 3 over 3 squared. 3 squared is 9, so I'll have negative 3 over 9, which reduces to negative 1/3. Okay, so here is our slope. Okay. All right, now we need to find the tangent line. Which means we have the slope. Now we need a point. They gave us an x value. How can we find the y value? Well, we could plug it in. So the x value is a 3. If we plug in a 3 for x, 3 divided by 3 is 1. And now we have the y value. So let's maybe put that up there just to remind you how you got that. Okay, so there's my x, there's my y. We can write our tangent lines. So f of x equals the slope times x minus the x value is a 3, and then the y value is positive 1, so plus 1. And of course, we've got to simplify. So we have to distribute that negative 1/3. So we'll get negative 1/3 x. Negative 1/3 times negative 3. Negative times negative is positive, and 1/3 of 3 is 1. Okay, I think we can see what our final answer is going to be. It's going to be f of x equals negative 1/3 x plus 2. There's the equation of our tangent line. And I bet you're looking at that graph that my hand is hovering over. And yep, we're going to have to graph it to verify. Check by graphing. Okay, so let's start with the function y equals 3 over x. So I'm going to write it over to the right here. Y equals 3 over x. We know how to graph these. We learned how to do that in Math 3 last year. Okay. It's got a big bottom because the highest degree is the 1 and it's in the bottom. So big bottom. So that means it has a horizontal asymptote at y equals 0. So I'm just going to use my highlighter to graph the asymptotes. So horizontal asymptote at y equals 0. And there's a restriction in the denominator. X cannot equal 0. So that means I have a vertical asymptote at x equals 0. So that's that vertical line there. So I'm going to mark that with my highlighter. Okay. And now I need to make a table to graph. Because I'm checking by graphing, I can't fake a lot of it. I have to try to be as accurate as I can. So I'm going to use a table. I know that it has to coincide good with that line. So, and I know that it has to be along this point 3, 1. So I'm definitely going to try an x value of 3. And I might as well try an x value of 1. And might as well do it on the other side since it's symmetric. So let's try a negative 3 and a negative 1. Okay. I can't do 0 because it's undefined at 0. Right? Can't put 0 in the denominator. All right. So if I plug in a 3, 3 over 3 is 1. If I plug in a 1, 3 over 1 is 3. If I plug in a negative 3, 3 over negative 3 is negative 1. If I plug in a negative 1, 3 over negative 1 is negative 3. Okay. All right, so let's plot these points. 3, 1, and 1, 3. So we can kind of fake the rest of it. We know what these look like. Just hugs the wall. The point that we care about is 3, 1, though, because that was the point that was given up there. And then for the other part, it's negative 3, negative 1, and negative 1, negative 3. So this part we can fake. Okay, it's so pretty. All right, so now let's do the line. The line has a y-intercept of positive 2. And then our slope is negative 1/3. So I'm going to go down 1 over 1, 2, 3. Down 1, 1, 2, 3. And I have, oh my gosh, I just drew a really perfectly straight line. I'm very, very proud of myself. Oh man, there's our tangent. And here is our f of x. And we just verified it. Woohoo! All right, example 3. Let f of x equal 1 over x. Letter A. We're going to find the slope of the curve at x equals a. Okay, so this time we're doing everything we did, except instead of giving us an actual number like they did up here, they're giving us the letter A. We can do this, okay? So we have to find the slope. That's what it said. So that means I'm taking the derivative. So f prime of x equals the limit as h approaches 0 of, actually we're changing it to an a, so f of a. So limit as h approaches 0 of, the function is 1 over x, so 1 over x plus h minus 1 over x all over h. Using the derivative formula. Got to get a common denominator. So just like I did up top, I have to multiply top and bottom by x on this one, top and bottom by x plus h on the other one to get that common denominator. Okay. And then I'll have the limit as h approaches 0 of, I know it's all over h, I will have in the numerator, that denominator is going to have a factor of x and x plus h. 1 times x is x. Negative 1 times x is a negative 1x. Negative 1 times h is a negative 1h. We can cancel stuff out, like those x's. They gone. We can rewrite this. I have some room right here, so I'll rewrite it. So I'll have the limit as h approaches 0 of, I have negative h over x times x plus h, divided by h over 1, but dividing fractions is easy as pie. Flip the second and multiply. And then these h's cancel. They gone. Okay. So in this step, let's go ahead and plug in the 0 for h. And let's also plug in the a for the x's. So we can just do a 3 and 1. Okay. So that will give me negative times 1 is negative 1. All over, substitute in an a for the x, 0 for the h. All right, a plus 0 is still a, so it's negative 1 over a times a, which is a squared. So this would be the slope of the curve at an x value of a. A, okay? I know, I'm a nerd. Can't help it. All right, letter B. Okay, it says, where does the slope equal negative 1/4? Well, I just found the slope, the negative 1 over a squared, and I need to figure out, well, where does it equal negative 1/4? Okay. So that means set it equal to negative 1/4, and then you'll find what a value will make it equal negative 1/4. Whenever you have a fraction equal to a fraction, this takes you back to junior high, you cross multiply. Multiply cross. So negative 1 times 4 is a negative 4. A squared times negative 1 is a negative a squared. We are going to need to take a square root pretty soon here, but we can't with that negative out front, so we have to divide both sides by negative 1. Negative divided by negative is positive. How about them apples? Okay, and so we'll have a squared, I'm going to flip it around, equals 4. Square root both sides. And we'll get that a equals, whenever we're solving for a variable and we're taking a square root, could be plus or minus 2. So that means the a values that will make the slope be negative 1/4 are an a value of 2 and negative 2. Okay. And then letter C. It says, what happens to the tangent to the curve at the point a, 1 over a, for different values of a? Okay, so a and its reciprocal for different values of a. All right, so when a is 0, if we plug in a 0 and the reciprocal of 1 over 0, it's still going to make it 0. Okay, so as a is 0, that means the limit as a approaches 0 from the left or the right. So we can even use this graph because 1 over x is pretty similar to 3. Which one was this one? 3 over x. So as we're approaching 0 from the left and from the right, it's going down to negative infinity up to positive infinity. Okay, so it's going in opposite directions, but to infinity. So of negative 1 over a squared is going to equal plus or minus infinity. Okay. So what that means is that it's either getting steeper and steeper and steeper going up, or steeper and steeper and steeper going down. So steeper and steeper. That's what is happening to that slope. Okay. Another point that we should try is as the graph goes to the left. That covers a pretty wide expanse. As a goes to left, oops, I need to spell left correctly. When we're going to the left on a graph, we're going to negative infinity. So the way I write that is the limit as a approaches negative infinity of negative 1 over a squared. Well, as we're going to negative infinity, the y value that we are approaching is going to be a 0. So the limit will be a 0, which means the slope is a 0, which means if the slope is 0, this is a horizontal line. Okay. Well, if we're looking as a goes to the left, we probably should look as a goes to the right. And if we're going to the right, that means we're going to positive infinity. Okay, so that would be the limit as a goes to infinity of negative 1 over a squared is going to equal, well, it's going to positive infinity. It's also going to be approaching that y value of 0. So it's going to also be a horizontal line. The slope will be a horizontal line at that point. Okay. Now this is not 1 over x, it's 3 over x, but the 3 on top just makes it fatter, but it's still going to be the same end behavior. Remember we talked about that? All right, next. The normal line. Bet you were wondering about that. The normal line to a curve at a point is the line perpendicular to the tangent at that point. So back in the day, like back in Math 1 days or even 8th grade math, 7th grade math days, you know, way back then, you learned about lines and you learned about lines that are parallel and you learned about lines that are perpendicular. You learned that parallel lines have same slopes and perpendicular lines have opposite reciprocal slopes. So you have to dig up that old information. And remember that perpendicular lines have opposite reciprocal slopes and they always intersect at a 90-degree angle. That's what it means to be perpendicular. So like a wall in your room and the floor, they're going to meet at a 90-degree angle. This stack of Post-its on my table are meeting at a 90-degree angle. Ooh, my Instant Pot went off. That means dinner is done. All right, I'll let it slow release. Okay, so example 4, it says write an equation for the normal to the curve f of x equals 4 minus x squared at x equals 1. So we're looking for the normal. So we're going to write an equation for a line that is normal to the curve. So perpendicular to a point on that curve, okay? And here we go. So because it's perpendicular to the tangent at that point, that means we still have to find the slope of the tangent. So we're going to start with that. Slope of tangent. So we're still doing the same things that we did in the last few problems. You'll see what's different. So if we're finding slope, that means we're taking a derivative. So f prime of x equals the limit as h approaches 0 of, it'll be 4 minus x plus h quantity squared minus the original, which is 4 minus x squared, all over h. Okay. In the next step, we'll have the limit as h approaches 0 of, we know that x plus h quantity squared multiplies out to x squared plus 2xh plus h squared. Okay. I just have to distribute this minus sign to everything there because it's in front of the parentheses. Okay. So that will be 4 minus x squared minus 2xh minus h squared. Then I also have to distribute this negative. So that will be minus 4. Negative times negative is positive, so plus x squared all over h. And then we can get a little cancel happy. 4 and negative 4, they gone. Negative x squared, positive x squared, they gone. So now all I have left is negative 2xh minus h squared all over h. Remember, all or nothing. All three have an h that I can cancel out. Boom, boom, boom. So now, let's rewrite this. We'll have the limit as h approaches 0 of negative 2x minus h. Okay? we can go ahead and plug in that 0 for the h, and we'll get negative 2x. Minus 0 is still just negative 2x. That's the slope formula. They did give us a value for x to plug in. It's this x value of 1. So negative 2 times 1 is negative 2. So here is our slope of the tangent line. Okay, but we need the slope of the normal line. So we're going to get that from this, because remember, the normal line is perpendicular to the tangent line. So I just have to find the opposite reciprocal of negative 2. So we're finding the opposite reciprocal. So if I write that as negative 2 over 1, the opposite of negative is positive. Hold on, let's put slope of normal. I'm getting ahead of myself. So the opposite of negative is positive, and the reciprocal of 2 over 1 is 1/2. So the slope of the normal line is 1/2. Okay, I now need the point. What's the point, Mrs. Garcia? Sorry, I'm being silly. All right, well, the x value is 1. So what's the y value when the x value is 1? Well, to find the y value, just plug it in. 1 squared is 1. So what's 4 minus 1? That's right, it's 3. So there's the point. We have the point, we have the slope. Now we can write the equation of the normal line using the same method that we use to write the equation of the tangent line. It's the same thing, it's just this is the normal line. All right, so we'll call it something else. We'll call it g of x equals, the slope is 1/2 times x minus the x value there is a 1 plus the y value is a 3. And then we have to simplify. So we have to distribute that 1/2. So that'll be 1/2 at x minus 1/2. Let's make that 3 have a common denominator with the 1/2. So multiply top and bottom by 2. And so that'll be plus 6. 3 times 2 is 6 over 2. Negative 1/2 plus 6/2. We should know the answer to that. So the final answer, the normal line, is the equation g of x equals 1/2 x plus negative 1/2 plus 6/2 is 5/2, which we know is 2.5. Okay, so we found the equation of the normal line. So we follow all the same steps to write the equation of the tangent line. We just then take that a step further. We have to take the slope of the tangent line, find its opposite reciprocal, and then plug it in like we did to find the tangent line. So it's really not that bad. Okay, let's graph this. So the original function was 4 minus x squared. So f of x, I'm going to write it differently. I'm going to reorder it. I'm going to put the negative x squared first and then the positive 4 because I like that better. So this tells me that this is the parent function shifted up 4, but that negative says it's flipped down. So the parent function starts at 0, 0. I got to go up 4, and it's got to be facing down. If I plugged in a 2, 2 squared is 4, so negative 4 plus 4 is 0. So I'm going to have a 2, 0 and a negative 2, 0. Just doing some math in my head. And there is, that arrow is horrible. It's because I turned my wrist a weird way. All right, there's my parabola. And let's go ahead and graph the tangent line. The tangent line, remember, has a slope of negative 2. And the point in question is the point 1, 3. So it's this one right here. So I'm going to start from that point since it's tangent to that point. And since the slope is a 2, I'm just going to go down 2 over 1. And go back to that point and do the opposite. Opposite of down 2, right 1 is up 2, left 1. And there is our tangent line. Okay, let's do the normal line. So the normal line has a y-intercept of 5/2. 5/2 is 2.5. So 2.5 is right here. And then my slope is up 1 over 2. So I'm going to go up 1, so that would be at the next halfway mark, and then over 2. and then go back to that point and do the reverse. Down 1 hole, left 2. So I'm going to try really hard to draw straight. Those that know me know how hard that is for me, because I'm just super shaky. So yeah, I shook through that line, but these lines definitely do look perpendicular. And let's label this the normal line. And let's also label our f of x, our parabola, our downward facing parabola. Perfect, that looks so nice. And don't worry, we're not doing example 5. All right, so your homework will be posted with this, and then you have the chapter 2 review on Edulastic to do, and I will post a video going over that review probably on Monday. So I'm going to make the review due Sunday night to make sure that you have it done, or I'll make it Monday. Well, I don't know what I'm going to do. But anyways, I do want you guys to try it. If you want to try the review multiple times, let me know and I can redirect it to you. That's not a problem. The review will be a definite good way for you guys to practice these problems. And there will also be a practice FRQ to do as well for review. Alrighty. All right, guys, have a good one. I'll see you later.